What I will do in this video is I will explain how to find the equation of a line of best fit. Now, first, what I want us to think about is I want us to think about an equation of a line and to recall that we had the general form y equals mx plus c. So this is one way to have the equation of a straight line where we have y and the coefficient of y is 1. And then we have mx where m is the gradient and x is there, and m is also the coefficient of x. And we have a plus c here, which is the constant term, and this is also where we're going to find the y-intercept. So this is the way that we used to have it. Now, in statistics, what we're going to do is we're really going to have the same thing, but we're going to write it y equals ax plus b. Okay, so our x and y values, or x and y axis, they're still the same. A is now where we're going to find the gradient, and b is where the y-intercept will be. Now, before we move on, I want to say the method that we're going to use to find the equation of a line of best fit. The first thing we're going to do in our method is we're going to identify some points so that we can find the gradient. So we will be able to find what the value of A is. Okay, so we will be able to find what the value of A is, and that's the one that we're going to find first. And I will show you how to do that in a bit. So I'll show you one example. So we're going to know what A is, and we're going to have to find B. And I'm going to show you what you can do to find B. So if we're going to know what A is, and we're going to know a pair of values x and y, okay, and we might actually know two pairs of values x and y, but we're going to choose one of them, and we're going to use it to find the value of B. So all we're going to do is once we know what A is, we know that this equation can be rearranged by subtracting ax from both sides. And then we can see that we're going to have y take away ax, and that's going to be equal to b. Now, these values we will know. So y and x values we can get because we found or we identified a point on our straight line. And the a value we will know because we had identified 2 points actually, and we found the gradient. Okay, so if we do this calculation with a pair of x and y values and the a value that we found, we will be able to find what b is. So here's an example of a scatter graph, and what I've done is I've plotted the mean point and I've drawn a line of best fit for it. And what we're asked to do is find the equation of the regression line. Okay, the regression line is another name for the line of best fit. Okay, so I've already explained how we're going to do it. Now I'm going to show you what it looks like when we're actually doing it. So we need to identify 2 points on this line. Now, normally our line is going to be on graph paper like this, and we should be able to identify somewhere on the line where the line is going through these crosses. Okay, so these lines going down and lines going across, we're trying to identify that. Now I can see that this point here is a good point to choose, so I'm going to choose that point, so this one there, and I can see another one here. Okay, so these are the first two that appear to me as going through the crosses of my grid. Okay, so where the line or my line of best fit or the regression line is going through the crosses of my grid. So that's one, and that's another one. Let's identify what the x and y values are for each of them. So for this one here, I can see that the x value is 20, and the y value will be, so if this is 225, then each of these are jumps of 5. So the y value will be 205. 20 and 205. So this is 20 and 205. And this one here is, so it goes from 5 to 10. So every 2 boxes is 1. So that's 6 and that's 7 there. So that's 7 and 100. So we have 7 and 100. So I've identified 2 pairs of x values. So this is one x and y values. So this is one pair and this is another pair. I'm going to use them to find the gradient. Now, if you remember, the gradient is a measure of how far up you go for every 1 unit going forward. Now, using these 2 points, we can do that because we can find the difference in y values, so how much up it's gone, and we can find the difference in x values, so how far forward it's gone, and just divide it, okay, to find out for each one jump how much up roughly we're going. Okay, so I'm going to draw a rough sketch of a triangle here. So if I sort of go across like that and go down, and I'm looking for the difference in y value. So 205 to 100, that's 105. So 205 take away 100 is 105. So that's a 105 here. And the difference in x value is from 7 to 20. So 20 take away 7 is 13. So this is 13. So we've gone 13 jumps forward and 105 going up. And what I can do to find the gradient is this number divided by that number, 105 divided by 13. And that gives me, so I'll write that down first. So 105 divided by 13, that gives 8.076923. Okay, I will round it afterwards, but for now I'm going to write that. So this is my gradient. Let me write the general form of the equation of the regression line. So y equals ax plus b. Now, I've just found my a value, okay, and I'm going to round it now, and I'm going to put it here. So I'm going to round it to 3 significant figures, so it's going to be 8.08. So y equals 8.08x, and then plus b. Notice I've put a decimal number here, and I've rounded it as well. Previously, you may have put a fraction here, but when we're doing statistics, we're going to use a decimal, and that's fine. Now I want to find the value of b, and what I showed to you before is if I subtract this bit and move it to this side, okay, I get an equation where we've written it in terms of b. So b is equal to y take away 8.08 and then x. Okay, now to find the value of b, I can choose either one of my points. Okay, so either 7, 100 or 20, 205, and substitute those values for x and y and find the value of b. I'm going to use this one because this one has easier numbers, really. So we're going to have b is equal to, my y value here I can see is 100, so this would be 100 here, 100. Take away 8.08, and I need to times that by 7, I can see here. Okay, so the 7 will go there. And I'm just going to multiply that, and I'm going to do 100, take away this value here. And that's going to give me my value for b. Okay, so I'm going to put that in the calculator now. So I've got 100, take away 8.08 times 7. And that gives me 43.44. So b is equal to 43.44. And now I'm going to write the equation of this line, okay? So equation of that line is going to be y is equal to 8.08x plus 43.44. Now, I could have used, instead of the 100 and the 7 that I used here, I could have used 205 here and 20 here, and I would have actually got the same value there. Okay, so either one gives you the same value. And in the end, I'm writing my equation of the line, and my equation of the line will have the variables y and x. My a value will be written in, and my b value will be written in as well. So here's your task. You've got 2 graphs to look at here, and I've drawn the line of best fit for you. You need to find the equation of the regression line. What I'm going to do is I'm going to zoom into each of these for a few seconds so that you can see more clearly, and you'll be able to identify the points a little bit more easily.